Yes, so we've got the truly brave people who have decided to go into the masterclass. So yes, I can see some people have hung around from the last session, so I haven't scared off absolutely everyone. So this session, for those who didn't meet me before, I'm Dion McMurtrie. I work for CSIRO, or CSIRO, which is Australia's national science agency. The bit I work for is part of the Health and Biosecurity Division, which the sub-bit we're in is the Australian e-Health Research Centre. So we're Australia's digital health program, research program. And we do stuff like OntoServer is probably the main relevant thing to this talk, but lots and lots of stuff. So this particular talk goes into a bunch of different kind of more advanced features of the terminology service. So we'll take just a wander through CodeSystem Supplements. So we talked about code systems in the last thing. This is about supplements. What are they? How do you use them? When do you use them? Dive a bit more into implicit value sets, or particularly SNOMED CTECL, and how that's really good for ad hoc querying. Go through the transitive closure table, which was one of the questions from the last session, and unfortunately the person who asked that had to go to another session, so hopefully they'll watch the recording and hi, this is your topic, will be up later. Composing concept maps, which is something people don't always know that you can do, or it's not always obvious that you can do, but it can be quite a useful thing. And then the last thing is a kind of a new thing, which is how the FHIR tooling ecosystem, like the the IG publisher and validator and whatever, gets access to terminology infrastructure, particularly to figure out what authoritative sources for terminology resources are. So assume knowledge. Essentially, I'm going to assume that you either know all of this stuff or absorbed the last topic I just presented on the basics of how FHIR Terminology Services work. There's also, this is in the presentation, you can have a look at it later. For all of the examples that I give in this presentation, there's a Postman collection, so you can try all this stuff out for yourself and tweak it and play with it and muck around with it. Particularly for supplements and things, it's quite cool to have, because getting it to all work can be a bit confusing. So, augmenting a code system. We'll start with CodeSystem Supplements. So there are heaps of code systems maintained by other people all around the world, which is awesome, because maintaining code systems is hard. Many of those code systems come from HL7. There are big code systems published by like SNOMED International, there's LOINC, there's RxNorm, others. And then there's a bunch of local and regional code systems that there's thousands of them, unfortunately. But what if you're using one of those code systems and you need to do something like customize a display term? Or more particularly, what if you're trying to translate that whole code system into another language even? Or maybe you just want to add a property to a code system's code. So as I was saying before, maybe as a fictitious example, you've got a medicines terminology and you want to annotate all of the codes for the various products with whether they're available in the market in your jurisdiction or not, or what the price of them are, or what the subsidy is for them. So you could ask the code system maintainer to change the code system, to add these things in. And honestly, you probably should if it's a generally useful thing that would benefit everybody, and that would be good. But you don't really know if or when that's ever going to happen, and particularly if it's something local to you, like whether it's that medication's available in your jurisdiction or not. Well, they're probably not going to do it. So this is really where CodeSystem Supplement comes in, for extending codes in an existing code system that you don't own or maintain, because if you owned or maintained it, then you just add the properties into the code system yourself, with additional properties and additional designations, including language translations. But what it's not for is adding new codes, additional codes. So that's the limit. You can add properties and designations, you can't add new codes. And it gets used in the context of a value set, so it affects the expand results. It'll change the display term that comes back, on obviously designations if you ask for them in the expansion, and it will also add the available properties in. I've got some examples of how this happens. Just a quick digression. So how do translations work in FHIR anyway? Of course, there's a DevDays presentation which explains all of that. So from Renee from 2021. But the basics of how it works is at this URL, tells you all about it, but essentially it's just HTTP. So it's just like you do for anything else in the web, which is great. There's accept language headers, and then you'll get content language headers for request headers and response headers. Pretty simple. Of course, there is also a display language parameter that you can send in with the request if for some reason you can't make the headers work, which is common to pattern in FHIR. So adding a translation to a code system, here's an example where you can see at the bottom here what we're declaring is just a code system resource, and we're calling it multilingual administrative gender. And at the bottom here you can see we've declared the content type for the code system to be supplement, instead of it being a regular code system. And there's an element here which is declaring the code system that this code system resource is supplementing, which is the administrative gender code system. And then when we look here, we can create, we can add onto the code a series of designations. So this is a Portuguese, Spanish and Estonian translations of the concept for male. So there's the Portuguese example, and it's got a, it's not just the value and the language code that's been added, but it's also got a use code to say that this is preferred. So this is now in the context of this CodeSystem supplement, in Portuguese, this is the preferred term. So how do we use that thing once we've got it? Well, we need a value set that kind of engages or invokes this CodeSystem supplement. So the two main bits to look at here, one is down the bottom here, we're saying include all of the codes from the administrative gender code system. So we're not actually talking about the CodeSystem supplement down there. The definition of what's in the value set in terms of which codes are in the value set is the underlying normal code system. And then we've got this extension at the top here, which is saying that this CodeSystem supplement should be used in the context of this value set. Now, interestingly, in R5, and I've included this in R4 because, let's face it, most people are still using R4, there's a new parameter in R5 where you can, instead of doing this extension, you can pass that parameter in the request to say use this supplement when you're going to produce this expansion, which is super handy, and so you don't have to pre-declare it in the value set. And we've pre-adopted that parameter, so you can try that out. Anyway, this is what using our translation looks like. So I'm going to expand the multilingual administrative gender value set that I just defined on the previous slide, which is just expanding all of the codes that are in the administrative gender code system. And I'm passing in an accept language header of Estonian. And what I get back is this, which is telling me about the code systems that got used. So you can see here that it's actually telling me about two of them. One was the administrative gender code system, and then the other was my supplement. And then all of the names, the display terms over here are all in Estonian, and that's sort of basically the way it works, which is kind of good. So if we're going to add properties, it's basically the same pattern. So we have to declare that we've got that we're creating this code system, and that this code system is a supplement. So its content type is supplement. We're declaring what it's supplementing, which is LOINC 2.74. We're declaring a property. So this property exists in this supplement. It doesn't exist in normal LOINC, which in this case is a preferred unit. And we define the normal metadata that we would define for a property in a code system. And then down here on this particular code, and we only have to include the codes in the supplement, which are the ones we're wanting to annotate with whatever this new property is. We've added the new property there with a particular value. And you can see there's a count of only one, so I've only got one concept in there. Once again, we'll need a value set to be able to make this work. So this value set just says that it includes everything in LOINC 2.74, and it has the same extension that we mentioned before, which you can also use the useSupplement parameter that I previously mentioned as well in R5. So let's have a look at what an expansion looks like with that. So what we're doing here is expanding the LOINC unit value set, which is that value set that I defined that uses the supplement. And I'm expanding with a filter that I know matches up to that code that I put the property on. And I'm saying in this expansion, property equals preferred unit. So all this is doing to the expansion, and you can do this without the context of CodeSystem Supplements. You can ask an expansion to include properties from codes in the expansion result. You can actually say property equals star to say include all of the properties if you want to. I think the server can reserve the right to not do that, but ours does. So, and this is what you'd get back. So you get back the LOINC code, and then plus it's got this extension on here, which is adding on the additional property that we defined before as the preferred unit. So they appear as part of that expansion. So thinking about what this is like in real life, there is a thing called the lab code set in the Netherlands where we implemented this to be able to annotate LOINC with a number of properties. So it adds a status, material, a UCOM unit, and a translation for a whole chunk, like many thousands of LOINC codes, and then you can end up using expand with properties to get these properties back, and obviously if you use the accept header, you can get back Dutch translations. So what are the implications of this for validation? So that's an obvious next step. So value sets can define display values for codes. So you probably would have seen that where if you create a value set, you define you enumerate a set of codes in the compose section to say this value set contains this set of codes, and then on the in that you can include a display, which you're effectively overriding what the default display is for the code system for that code. In the context of that value set, it now becomes the display text that you've put in that value set. Perhaps what's not so well understood is that you can only do that with a value which is either one of the other designations for that code in the code system, or you can actually use one of the designations from an involved CodeSystem supplement. You can't just pick any random text you like. Well, in fact, you can, and people do, but it isn't valid. So that's the right way to do it if you're wanting to pick a bit of text that isn't one of the designations from the existing code system. Right, so moving on to a sort of a slightly different concept, let's talk about querying a code system. So if I want to do something like I want to find out what are all of the SNOMED CT codes that are an edema of the trunk and also a disorder of lung. So I'm sort of intersecting those two things together to find out what concepts are both those things. So first I need to make a value set and then post it into the server. So this value set's just got a really simple definition. It's a descendant of both of these two different concepts. And then now I can expand that value set by calling the expand operation on the value set that I've just created, this explicit demo. And you can see here this has come back with 30 results, which are all of those things. So that's worked. But then what if I decide now that I want to know all of the things that are lung disorders that aren't edemas? So what if I kind of change my mind and I want to see something else? So one way to do that is I could update that value set that I just created, put it over the top of the last version, or create a whole new value set, I suppose, and then expand it again. And that's all a bit tedious. There is sort of a shortcut to that that's existed for a long while, which is I can actually post a value set to the expand operation. So instead of using a get request for the expand operation, I can use a post request, and I can include in the body the value set resource that I want it to expand, instead of specifying a URL of a value set resource on the server that I want it to expand. And what the server is going to do is evaluate this value set resource and get the expansion result, return the expansion result, and then drop the value set resource on the floor and never use it again, kind of thing. So it's only for that one request. But that's kind of still a bit tedious. It's very verbose, and the post requests don't cache very well in web caches, and GET requests are better for that. So that's kind of a bit annoying. So this is where implicit value sets really are kind of a lot more powerful and a lot more useful. So instead of creating a value set resource, I can just expand one of those special URIs. So things like SNOMED CT and LOINC, RxNorm, UCOM have got these implicit value set URIs, which are essentially just a syntax for defining a URI which has a particular meaning that the terminology server will then know how to evaluate and return you an expansion. So here are a bunch of ones for SNOMED CT. So the first one there is just going to return all the concepts that exist in a particular edition or version of SNOMED. That's not so interesting. The next one is all of the concepts subsumed by the specified concept. And so this is, by definition, there's one of these unique URIs for every concept that exists in SNOMED. There's the concept of reference sets in SNOMED, so very similar to value sets in that you can have reference sets that group a set of concepts for a particular purpose, only in SNOMED, obviously. So this URI will get you a list of all of the reference sets that exist in SNOMED, which are things that you might then want to use in expansion requests. The next one is expand a particular reference set, so get me all of the concepts that are in a particular reference set. And that's great, because then now, instead of having to define an explicit value set for every reference set, if I want to expand them, I have syntax to be able to do that. Probably the last one is the most powerful, though, which is, so there's an example of this particular call. You just pass it in as the URL with FHIR value set is or equals this particular value. But the last one's probably the most powerful, which is ECL, where you can use SNOMED's ECL, which is a expression constraint language. You can think of it like a query language for SNOMED, to be able to write a query which will match the particular concepts that you want returned back. And it can be used to fulfill at least the ref set column, this ref set one, and this ISA, as well as this one at the top. It can do all of those. So I'll go through a really super brief overview of what ECL looks like. It's actually quite big and rich, so it's hard to cover anywhere near all of it, but this will give you an idea of roughly how it works. So you can look for things like descendants of a concept, or descendants and self, so this different syntax. This second one will include the diabetes mellitus concept as well as all of its descendants. This one won't include clinical finding, but it will include all of the things below it. You can do child, which is just one level down. You can do parent, one level up. You can do ancestors, so everything that's above, everything that subsumes this concept. And then you can do member of, which is, again, for reference set, so everything that's in a particular reference set. It gets more complicated. You can deal with attributes, so you can do things like this first bit of ECL here is saying, I want to find all things that are subtypes of disorder of lung that have an associated morphology of edema. And I can get even more complicated and say that I want a clinical finding that has a finding site of something below, like pulmonary valve or some substructure of pulmonary valve with an associated morphology of stenosis. You can get into attribute grouping as well. So SNOMED does group things. So there's times where, for example, a clinical finding might have two different finding sites with two different morphologies, and you need to be able to say this morphology goes with this finding site and this morphology goes with that one. So that's what the grouping mechanism is for. And then you can have further constraints. This might be a bit subtle at the bottom here, but this is saying, find me all descendants and self of clinical finding with an associated with edema, but the associated with, it's basically saying the associated with property or any sub-property of associated with as well. And then we get into much more examples. So this top one is actually saying, is using concrete values. So we're saying, this top one's actually saying, find me all of the medicinal product concepts, like the drug concepts, which are oral dose form amoxicillins between 250 and 800 milligrams. And you can do things like this, which is actually saying, find me all of the fracture of bone concepts. But instead of returning the fracture concepts, it's actually finding the finding sites. So the result of this query wouldn't be fracture concepts, it would be bones, essentially, anatomy. Cardinality, you can say this is a pharmaceutical product that has between 1 and 3 ingredients. And then you can do all sorts of operators like and or, minus, to combine all of these things together. So as you can imagine, it can get probably quite complicated, but quite powerful. So going back to the original things that I was talking about before and what I wanted to do, there's no need for me to create anything. I don't need to create any value sets, and I can just run these two GET requests, essentially. The first one's going to find me things that are both edema of trunk and lung disorders, and the other ones are going to find me the lung disorders that aren't edemas. So it's much more compact, but it caches really well in web caches, which is really useful and important. There's a bunch of different ECL builders around. Like there's one there, but there's others. SNOMED International's got them. But these things are really great for doing ad hoc querying and analytics and that kind of stuff. So another thing that it's really useful though for, and this is, I mentioned this in the last presentation, this is really worth going and checking out and having a play with, this SNOMED UI demo, showing you how dynamic interfaces can work. So this particular example here, we've picked a procedure of a lung excision, and what we've been offered then is laterality of left, right, and left and right. I guess you've got a real problem if you've got left and right, but anyway. And then if we select left apectomy, we're not being given any, so the laterality's been grayed out, and liver resection, laterality's been grayed out. So how have we done that? How have we decided that those things weren't lateralizable, so we should not let someone say something silly like select left apectomy and laterality right, and then what does that mean? So how that's been done is essentially the very first bit, presenting the procedure to the person, is just this URL here, which is an implicit value set, which is all descendants of procedure, I guess that is. I don't actually know what that SNOMED code is. And the filter, someone's just typed lung X, so the top result there is lung excision. Then this particular code's been put into this bit of ECL below, so you can imagine that being templated. And this bit of ECL is saying, find me all the, find me lung excision dot procedure site. So find me all of the procedure sites and subtypes of procedure sites that exist for this lung excision concept, and intersect that with all of the things that are lateralizable. So either I'm going to get back something, which are the lateralizable things, or I'm going to get back nothing, which means that there's nothing that's lateralizable. And then on the basis of that, I can decide whether to show anyone options for lateralized sites or not. So what if all code systems could have a thing like ECL? So it's great for SNOMED. I use it all of the time with SNOMED. It's really, really powerful and awesome. But we don't have that for other code systems, so we have to create these explicit value sets and expand them and update them, and or post them, and it's really annoying. So it might not just be a dream for me. There's a plug for Michael Lawley, my colleague, who'll be talking on Thursday at 9:25 about VCL, which is essentially the same concept as ECL, but it's for it's the ValueSet.compose language. So imagine the semantics for the compose section of a value set where you can define filters. It's actually slightly more expressive than that, where you'd be able to add that on the end of a GET request and be able to dynamically do the same sorts of querying, which is pretty cool. So we'll get into hierarchical queries quickly. So the subsumes operation. We can, and I think we did this example before in the last talk, we can look at the relationship between two concepts using the subsumes operation, and in this case, this operation is telling me that the excision of liver subsumes hepatectomy or total left lobectomy. But that's one code at a time, right? So, or two codes at a time. So that's pretty slow. So, transitive closure table, this is really what this is for. So imagine we've got this collection of nodes, A, B, C, D, E, and F, and they're joined up with the blue lines here, and those blue lines correspond to these edges over here. So B, there's a B to A edge, an E to A edge, C to B edge, D to B edge, and an F to E edge. So if I figure out what the transitive edges are, so I've got an edge between C to A, D to A, and F to A. And so I can add those into this table, and this is effectively becomes a transitive closure table, a really simple little transitive closure table. And then I can do something like this if it was in the SQL world or any sort of tabular type of analysis, where I can say, find me all of the things that are a subtype of A using this transitive closure table. I can join that to my record table and find out all of the records which have a code that is, like in this case, fictitious example, condition code that's some type of A. So you can do this with the FHIR Terminology Service. There's algorithms around, and you can get a transitive closure for SNOMED. It's really big, and you have to figure out the algorithm to create it, or you can get scripts. But you can use the FHIR closure operation to do this. And one of the best things about that is it can create a transitive closure of just the codes that you're using, or just the codes that are in your data. So normally you would just pick up, these are the codes that are in my data. Maybe it's 10,000 things, maybe it's more, but you know, SNOMED's huge. It's hundreds of thousands. And then you have a kind of a stateful interaction with the server to get these edges. So I'll go through a stateful interaction. You'll get the idea, hopefully. So first we've got to create the transitive closure table. It's one of the few stateful kind of conversations you have with the terminology server. So first you've got to create it, and I'll create one here called DevDays 24 DMC, and I just get back this simple response saying that it exists. So then I can send in my initial codes. These are the two codes that I had before. I can send them in to the transitive closure table and say, add these to my closure table. And what I get back is this response, which is the same as the response I had from subsumes before, which is telling me that that this is subsumed by the hepectomy is subsumed by the excision of liver. Then that's sort of not so interesting. Now I can add some more codes. So let's say I had those two codes in my data before, and now I've got these two additional codes in my data, and now I want to know what the relationships are with those. So instead of sending all of the codes in, now I only have to send the two new ones I've got, because it already knows about the existing ones. And what it's now going to send back to me is the new relationships that exist between the two new codes I added and all of the original codes that it already had in the transitive closure. So it hasn't sent me full transitive closure table, it's just sent me the new edges as a result of me adding these two things in. But if you forget, if your client side forgets all of the edges, you can go back and say, hey, just give me all of the edges that exist in this transitive closure table that it has built up over time. And that's just this request here. I'm actually asking basically for version 0. So go back to the start, give me everything. And it'll come back, and these are all of the edges that it's come back with to say these are the relationships between all of these codes. So quickly going on to concept maps, because I'm probably going to run out of time. We talked about concept maps before and how they relate to value sets. So what if you've got a really, really big map that maybe someone else publishes and maintains, but you want to tweak it. You want to change a few mappings out of it. You could copy the entire map and alter it, but then you've got to maintain it, and that's a real hassle. But you can compose concept maps together. And in fact, this is useful even if you're maintaining it yourself. You might be able to decompose the map into a few different units and then maintain those things separately, or maybe on different life cycles. So essentially, you can provide kind of new or even overridden mappings and then delegate on to a base map. So we've got an example of how that works. Basically, this works using the unmapped section of a concept map. So in the unmapped section, you can define use source code, which is essentially replay to the translate request the code that got sent in. Or you can have a fixed mapping for the unmapped section, which might be a value set or a code. Or you can say other map, which is just delegate onto this other map and do whatever it says. So we've got an example here of a base map, which is a mapping between the states in Australia and their capital cities. So New South Wales has a capital of Sydney, Queensland's got a capital of Brisbane, South Australia's got a capital of Adelaide, and so on. Probably nobody knows about this here, but there was a rugby league match last week, which is a big grudge match between Queensland and New South Wales, and Queensland lost. New South Wales lost again. I'm from Queensland, so I'm happy about that. So let's fictitiously take the example that our two premiers had a bet and New South Wales lost, and they have to temporarily change their capital to Brisbane, as it probably should be. So let's create the custom map, which overrides that mapping between New South Wales and Sydney to New South Wales to Brisbane. So here's our mapping down here in our what we've called our custom, our AU state capitals customised map, where we've got New South Wales now targeting Brisbane. And then everything else, it said unmapped mode, other map, and then there's the URL back to the original map that we've got. So if we go and do translation on that map, so in this case we're asking the customised map, so this is the URL is the customised map, and the code we're passing in is New South Wales. What we'll get back from that now is saying that it's related to Brisbane, not Sydney, so B&E over here, and it's told us that this mapping has come from the AU state capital customised map. So it's playing back where it got that result from to us. So the other translations that we're looking at are delegated. So if we go and ask the same AU states capitals customised map again about the capital of Victoria, which we didn't alter in our customised map, we'll get back that the capital is Melbourne, which is the way it is in the underlying map. And this time you can see here that the map that it's got the result from that it's telling me about is from the base map, and it's telling me that that's where that came from. So, and I'm once again running short, but running over time, but we'll quickly go through the FHIR tooling ecosystem. So this is relatively new. So if you think about the FHIR tools like the IG Publisher and the validation, how do they go and figure out what the authoritative source is for a particular bit of terminology to do what they do? Well, you can configure that stuff in, but there's a discovery service for that. So there's a terminology server registry. It's at this URL here, and it's based off this documentation that's in this GitHub repository, which you can go and have a look at. Essentially, that provides a registry and a discovery mechanism for the authoritative sources of the terminology. And the servers, for a terminology server to be involved in this, it has to pass these tests, which are at this GitHub repository, as well as be able to support certain metadata operations to be able to be in this ecosystem. So how does it work? There's a master registration file, which is in this GitHub repository, and that basically advertises the other registries for terminology servers available to the FHIR tooling ecosystem. The ecosystem is very much designed to support design time publication use. It isn't for kind of these servers that are being registered here aren't for runtime clinical applications and all that sort of stuff. It's an authoritative source for the purposes of publication, not for runtime use. And so this master references these individual registry documents. So there's an example of one there, which is actually in GitHub as well. So that's the HL7 terminology servers. And each one of those individual registries will basically advertise what they're authoritative for and the terminology server endpoints that they have that are authoritative for those particular sources. There's also this concept of a monitoring server. So this monitoring server, which is hosted at this registry, which is where the tools actually go and end up hitting and trying to resolve things, which we'll show you in a sec. And it's based on that master JSON file. So it'll read the master JSON file, follow the links to all the registries, find out what all the endpoints are, know what they're authoritative for, and then it will actually go and call those terminology servers and ask them for their metadata and their metadata terminology mode to get all the details of the code systems and things that they have and code system versions, and it tracks basically which endpoints do what. So what can a client do with this thing? And this is the page that renders the content of that registry at the moment. So a client can go and look around in the registry. It can filter the registry by the server and the FHIR version and supported code systems and that kind of thing. But probably the more interesting thing that it can do is there's a request to resolve what server to use for a particular code system and FHIR version. So there's a request at the bottom that you can see there, which is a request to resolve based on this terminology registry. And this example is registering for an R4, so specifically for R4. And it's asking for this terminology, which is SNOMED, but specifically this version of SNOMED, which is the July 2023 version of the Australian extension of SNOMED CT, and it wants to know, where can I get that from? So you can see here, it might be a bit small to see, but down in here, you can see here this server is being registered for AU. At the moment, there's only AU and HL7 registered, but I imagine there'll be more in the future. And the result that you get back here is saying that the candidates, there's a candidate here which is tx.fire.org, but the actual authoritative server to use for this particular version is the HL7 Australia server, tx.ontoserver.sire.au is where you go to get the authoritative source for that particular thing. The one other thing to be aware of is the usage flag. So this is kind of a mechanism to stop servers from being hammered by clients that don't sort of restrict themselves. So the administrator of the servers can declare whether it's okay to call this for publication only, or maybe for validation or for code generation purposes, because obviously validation happens a lot, publication happens a lot less. So there's this particular flag that you may have to pass through for that particular endpoint to declare what you're using it for, otherwise it might reject your request. Or not give you the endpoint that you need to use. And this is already supported by the FHIR tools. So what did we go through? Hopefully when, why, and how to use CodeSystem Supplements, how powerful implicit value sets are for ad hoc querying, and particularly with SNOMED CT ECL, but how awesome it would also be to have that for other FHIR code systems generally as well. So if you're interested, going along to Michael's talk. What a transitive closure table is and how you use that. How and why to compose concept maps, and that can be really useful even just if you are the controller of that code system, of that concept map, and you can decompose that into bits that you can manage sort of separately as well. And then a little bit of interesting history about what's going on with the FHIR tooling ecosystem and how the infrastructure works, and how you can register authoritative terminology server endpoints for particular content. And I imagine that'll be growing over time. So, obviously we've added ours, but I imagine we should be adding ones for like the UK and a number of other sources as well. So that's worth considering if you are an authoritative source for some of that content. So thanks. If you're interested in any of that, as I said before, I'll be around for the rest of the thing, but feel free to email me or my team, and happy to take any questions. Thanks.
Okay. Thank you, Dion. That was a really nice overview of some of the new functionality. How much of it has already been implemented, or is this something that we are going to see in the near future?
So all that functionality is like implemented and works in OntoServer now. And I think all of those features are already in use by some people. Like, so the supplements, for example, in the Netherlands are definitely in use, and Estonia as well. The ConceptMap thing used quite a bit. So yeah, no, it's all pretty much in use. The latest thing is probably actually that last thing, the FHIR Authoritative Source Registry, and that's only been relatively recent.
The one that you talked about, supplements, is that really for a situation where you don't have control over the code system itself? You don't want to change or enrich the code system?
Yeah,
but you want to add something to it.
Yeah, more or less. So I think, like all of these things, they should be used with caution. So there's, when you end up with multiple ways of doing something, obviously with the supplement, let's say for a translation, if you're wanting to do a translation of, let's say, SNOMED, you might be better off actually doing that with SNOMED International and getting that published as part of, a formal extension. But then there's plenty of other code systems that don't have mechanisms for doing translations, and so, it becomes a totally appropriate way to do that. Same for adding attributes on. It's not many code systems that have that ability to be able to arbitrarily add things to them. So it's a way to be able to kind of break out and do that without having to kind of take someone else's code system and make your own copy of it and add things to it, which is all horrible, and you shouldn't be doing that. So that's really what it's for.
Okay, we have time for a few more questions. I do want to mention that there's a group photo planned at 5:30, but if anyone else has any questions. Yeah. Okay. And sure. Of course, Dion's available after for more questions.
What do you see as, going back to that question I had asked earlier about enriching a code system if you have access to it? The way of doing it with supplements seems like very kludgy to me, right? It is, it's trying to bolt on something for which there is no good way to do it in FHIR.
Yeah.
So given a choice, if you can enrich a code system by, you're not changing the meaning of the terms, but you're adding annotation properties, would that be a valid way to do it?
Yeah, and look, there are a few ways to do that sort of thing. So obviously some code systems have native ways of you doing that, and that might be the right way to do it, to get it into the actual code system itself. But then there's plenty that don't. I think if you're wanting to do translations, alter preferred terms, you're kind of stuck with supplements for being able to get them in, particularly because you're going to want them into your whole validation ecosystem and everything, and that's how it all dovetails in. If you're adding properties, there are other ways. You can even do things like, but they're all kind of kludges. You can create a concept map to be able to say, well, for example, that example with Loink, saying what's the preferred unit for this particular thing. Well, I could create a concept map that gave me the preferred unit for this particular code. With the lab code set, there was almost like a cluster of properties, and so they didn't really want to map from one thing, the Loink code, to a preferred term or individual concept maps. They would have ended up with like 6 concept maps rather than just annotating the properties directly on. And then you can kind of filter you can define value sets using the properties to filter by the extra attributes that you've added, and so it's kind of it is a powerful thing. But yes, it should be used with care.
Yeah.
Yep. Okay. Thank you very much.
Thank you.